Welcome to the new discussions on statistics. This is about basic graphs used in statistics. There are four commonly used graphs. These are histogram, frequency polygon, ogive, and pie chart. You may use these different graphs in various purposes. However, examples here in this video of each graph will be limited to its purpose on the discussion on hand. To start with, we have histogram. This is the graph that displays the data by using vertical bars of various heights to represent the frequencies and class real limits. There are also histograms that uses horizontal, but the most commonly used is vertical bars. In the discussion, we'll use histogram to represent frequency and class real limits. Let's use the data of previous frequency table of 40 diabetics and let's construct its histogram. In our histogram, y-axis is for the frequencies and x-axis is for the class real limits. Don't forget to label each axis to show what are these numbers they are representing. Let's start. First class real limits is 9.5 to 22.5 and the frequency is 3. So representing its bar, it should be until 3. So it should be like this. Next, second class, we have 22.5 to 35.5 with a frequency of 4. Representing its vertical bar, it will be like this. Continuing this with other classes, the graph would be like this. Don't forget to label the figure by having it as figure 1. It should start with the type of the figure. In this case, it will be this. Figure 1, histogram of ages of 40 diabetics. So that's how you do histogram in statistics. Frequency polygon. This graph displays the data by using the lines that connect points plotted for the frequencies at the midpoints of the classes. It's important here in this graph to connect the endpoints in the x-axis. Starting point should be connected to the origin while the other endpoint should be connected wherever in the x-axis. The purpose of this graph is to show midpoints and frequencies of each class. Using the data of 40 diabetics, your y-axis again should be the frequency, and the x-axis must be the midpoints. So using the data, the graph would be like this. Don't forget to label this graph as figure 2 since this is our second graph in this discussion. So it will be figure 2, frequency polygon of ages of 40 diabetics. Ogive. This is the graph that represents the cumulative frequencies and midpoint of each class. This is like frequency polygon, but the difference, endpoints don't need to connect to the x-axis. Using the same data, let's construct now the ogive of this. This time, y-axis is for the less and greater cumulative frequencies, while x-axis is for the midpoints. Let's begin with the lower CF. Let's begin this with the lower cumulative frequencies. Plotting the points of first class, it will be like this. Continuing it until sixth class, the graph of lower cumulative frequencies should be like this. Next, for the greater cumulative frequencies, we will use different color to avoid confusion in the graph. Let's use green color in greater cumulative frequencies. Plotting the first class with its greater cumulative frequencies, it will be here. Next, second class, here. Connect, then continue this until you reach to the sixth class, and this is now the complete ogive of the data with the title Figure 3, Ogive of Ages of 40 Diabetics. Don't forget to label what is this black graph, same with the green black. Pie chart is also known as pie graph. It is a circle divided into sections or wedges according to the percentage of frequencies in each category of the distribution. I want you to attend to my class to know how to construct pie graph with the given data of 40 diabetics.